We're now going to turn to how to solve equations who you can't solve any particular other way, but we'll look into some graphical ways of solving a differential equation, and later sections some numerical, and finally some power series methods for finding solutions of equations. First, I should tell you, now that we've gotten to the end of the course, that only a small portion of naturally occurring differential equations can actually be solved through the methods that we've gone so far. I mean, I had to wait till the end to tell you that.
I am so glad.
Well, I'm glad you're glad that I waited till the end, because, you know, that way you wouldn't have been slacking through the first part of the course.
I am so glad.
Good. We're going to look first into a graphical method called direction fields.
I'm so ready.
All right, well, let's look into this. Suppose we got a differential equation as dy dx equals some function of x and y. Then on the curve f of xy equals c, in other words, whatever this is equal to c, the slopes of the tangent lines for the solution of the differential equation are the same, because, you know, this side and this side of the equation are the same. So the slope of the tangent line would be c, whatever that c would be. So the curves f of x equals c are called the isoclines of the differential equation dy dx equals f of xy, and they're curves in which the inclination of the tangent lines, that's the cline, is the same. That's the iso part. That's what that means. Isocline. Tangent lines are the same. And then if we would draw small lineal elements, like small line segments is really maybe a better way to say that. Draw small line segments representing the tangent lines at points along an isocline, we would be drawing a direction field, also called a slope field, of the differential equation dy dx equals f of xy. You can think of the direction field as a fingerprint of the functions y that are solutions of the differential equation. Although, to say it's a fingerprint, it's a little iffy to call it a fingerprint. It might be more likely to call it the graph of all possible solutions, and where the slope is would be where the graph is tangent to these little lineal elements. So let's look at our first example in the next video.